Okay, for our last lecture of this unit, let me take a look at questions 35 through 40. So find the probability of A union B. I asked for probability. That P front means probability. So because I said probability, I'm expecting one of my answer to be between 0 and 1. So I'm expecting a decimal number. Assume that events A and B are not mutually exclusive. Okay. So what does mutually exclusive and not mutually exclusive? Mutually exclusive means that my two probabilities, when I do my Venn diagram, A and B do not intersect. That's what mutually exclusive means. They don't intersect. They don't share anything. Now, non-mutually exclusive means they do. They do overlap. So let me do my two probabilities here. I'm going to do my Venn diagram, A and B. They do intersect. That's what not mutually exclusive means. So we have the probability of A is 0.43. Probability of B is 0.75. And the probability of A intersect B is 0.35. Okay, I have the intersection. So that means this space that they both shared is 0.35. Now, when I look at probability A, I'm looking at this whole circle that is A. If you notice, it's two sections, right? 0.35 is part of it. But notice how for probability A, I have the whole thing is 0.43. Part of it is 0.35. I'm going to say the other part is 0.08 because 0.08 plus 0.35 equals 0.43. You guys might be wondering, how did you come out with that? Honestly, what I did, I just went 0.43 minus 0.35, and that gave me 0.08. Again, I knew the whole thing. The whole probability A was 0.43. I knew part of it was 0.35. I subtracted those and I came out with 0.08. Having that said, let me take a look at probability B. Let me highlight. When I'm looking at B, I'm looking at this whole thing. All of this is probability B. And I see probability B is 0.75. So if I go 0.75, that's the whole probability B, and I take away 0.35, I take away part of it, it gives me 0.40, right? Or 0.4, 0.40, however you guys want to call it. Okay, have that. Now, when I look at the question initially, it says, let me do it in blue, find the probability of A union B. So I'm going to add 0.08 plus 0.35 plus 0.4. It is not always equal to 1. Some of people might be like, well, it's everything. Shouldn't that equal to 1? No, because we're going to call this. And let's say there were two things. Let's say A is people that play soccer. Right now they're playing soccer in high school. So people that play soccer. Probability B is people that do cross country. There's people that only play soccer. There's people that only do cross country. There's people that do both. However, there's also people that do none. So there's a percentage that could be outside. So let me add this up. I'm using my calculator. 0.08 plus 0.35 plus 0.4. And my calculator says 0.83. Okay, that's it. Now, some of people may be wondering, okay, we know how many people chose A, how many chose B, how many chose both, but that's not one, right? What if 0.83 is not one? How much do we need to complete a one? Like, how much is 1 minus 0.83? I'll type it in. 1 minus 0.83, and I get 0.17. I'm gonna write 0.17 out here. That is how many people. What's the probability of not choosing A or B, not choosing any. Okay. Because I was asking for probability. Remember, it says, what's the probability of A union B? I expect my number to be between 0 and 1. So 0.83 sounds right. That's it. Let's take a look at another example here. Find probability of A union B. Assume that events A and B are not mutually exclusive. So not means they do overlap. Here's probability of A, here's probability of B. I have the probability of A 0.75, probability of B 0.79, and probability of A intersect B. So the overlap is 0.61. When I look at probability of A is all this. So I know probability of A is 0.75. The whole thing is 0.75. Take away 0.61. That gives me 0.14. So this right here is 0.14. When I look at probability B, that's this whole thing right here. I know probability of B is 0.79. So this whole thing is 0.79 minus 0.61. That gives me 0.18. So this part right here is 0.18. Now I'm asking to solve for probability of A union B. So I'm going to go 0.14 plus 0.61 plus 0.18. I'm going to type it on my calculator. 0.14 plus 0.61 plus 0.18. And my answer happens to be 0.93. Because I was asking for probability, I was expecting a number between 0 and 1. So 0.93 sounds about right. Okay, let me flip the page. Let's take a look at number 37. Find the probability of A intersect B. Oh, interesting. A intersect B, assuming that events A and B are not independent events. Not independent, not mutually exclusive, the same thing. So that means that we have A and B, they intersect. So we have that probability of A is 0.59. Probability of B is 0.66. What's probability of A plus probability of B? Because if I was to add all of A and all of B, oh, I get more than one, right? But don't I expect probability to be between 0 and 1? So 1 point something, that's not correct. However, what happens, I'm going to say probability of A plus B is the probability of A union B. However, there is one section, let me highlight it. If I just add probability A plus probability B, that yellow section, I kind of added it twice, right? Because it is part of A, it is part of B. Let me subtract my probability of A intersect B. Okay, so looking at our formula, looking at our numbers, what do I really have? Probability of A union B is 0.81. It's equal to probability of A is 0.59. Probability of B is 0.66 minus probability of A union B. We don't know it, right? Isn't that what we're solving for? When we don't know the value of something, we just call it a letter. Let me call it X. Now that looks like an algebra question, so I'm just going to solve this. 0.81 is equal to 1.25, because that's these two numbers, minus X. For the space purpose, let me actually just continue over here. 0.81 is equal to 1.25 minus x. Okay, I'm trying to get x by itself, so this 1.25, let me move it over as a minus 1.25. So I get that negative 0.44 because 0.81 minus 1.25 gave me negative 0.44, and this is equal to negative x. Well, they're both negatives, right? Could I just ignore the negatives? Mathematically speaking, multiply everything by negative 1. So basically, the negative signs become positive signs. There you go. X is equal to 0.44, and that will be my answer, 0.44. Pretty cool. Okay, let's do a similar question. Let's take a look at number 38. A and B, assume that events A and B are not independent. So I'm going to say this is A, this is B. So I know the probability of A union B is equal to probability of A plus the probability of B minus the probability of the intersect. Remember, I subtracted because this area, basically, I added it twice. Okay, probability of A union B is 0.73. Probability of A is 0.6. Probability of B is 0.37 minus the intersect. I don't know what it is, so let me replace it with a letter. That's what I'm solving for. So it makes sense that I don't know it. So I have that 0.73 is equal to 0.97 minus x. I just combined like terms. That's really what I did. So 0.97 minus x. This 0.97, let me bring it over as a minus 0.97. So let's see, 0.73 minus 0.97, that gives me a negative 0.24. It's equal to negative x. Okay, well, multiply everything by a negative, so the negatives become positive. So I have that x is equal to 0.24. There you go. I expected my answer to be between 0 and 1, so 0.24 makes sense. My last two questions, let's see. Suppose that 50% of students surveyed like diet soda and 78% of students surveyed like Brussels sprouts. 41% like both diet soda and Brussels sprouts. Okay, so let me take a look at this right here. I'll read the questions in a minute. I'm gonna do something about diet sodas. I'm gonna do something about Brussels sprouts, so let me call that B. 41% said they like both. So as a decimal, that's 0.41. Now 50% said they like diet soda, right? So 0.50 minus 0.41 gives me 0.09. So that's right here. 78% of students said they like Brussels, right? Brussels sprouts. So 0.78 minus 0.41, that gives me 0.37. I'm going to put that right here. This is 0.37. Now, what is the probability as a percentage? Ooh, so I don't expect it between 0 and 1. I'm going to get my answer between 0 and 1, but then I will change it to percent. Okay? That a randomly selected student will like diet soda or Brussels sprouts. So what I'm going to do for that, for the adding, I'm going to go 0.09 plus 0.41 plus 0.37. That gives me 0.87. That's what it gives me right here, 0.87. If it was just the probability, 0.87, because I need it as a percentage, multiply this by 100. So it's going to give me 87%. Because I want it as a percentage, my decimal, my probability decimal, I multiply it by 100. So it gives me 87%. I don't have to write the percentage symbol. I'm just 87. Okay, take a look at here. Suppose that 71 students surveyed like Brussels sprout and 66% of students like dark chocolate. Okay, so I have something about Brussels sprouts. I'm gonna call this B. I have something about dark chocolate. Let's call this D for dark chocolate. 62% like both. So 62% as a decimal is 0.62. Okay, because 71% like Brussels sprouts, let me go 0.71 minus 0.62. That gives me 0.09. 66% like dark chocolate, so let me go 0.66 minus 0.62, which is the percentage that they both shared. That gives me 0.04. So that means 0.04 like dark chocolate, but not Brussels sprouts. What is the probability as a percentage that a randomly selected student will like Brussels sprouts or dark chocolate? Because I'm using the or, I'm gonna go 0.09 plus 0.62 plus 0.04. As a decimal, that gives me 0.75. So as a probability, 0.75. Now, because I want it as a percentage, let me multiply this by 100, and that gives me 75%. You don't have to type in the percent symbol, just the number 75.